I was asked by several students to make a short video to show you how to calculate the concentration of hydrogen ions from the pH. So that's what we're going to do. We know that the pH equals negative the log base 10 of hydrogen ions, of the concentration of hydrogen ions. What a log is, it's like opposite of an exponent. We're saying, what would I have to raise 10 to in order to get this number? What would I have to raise 10 to in order to get this number? And then I want the negative value of that, and that's our pH. So in our first example, when we have a pH of 6, the negative value of that would be negative 6. So what if I raise 10 to the negative 6 would equal that concentration? Well, that would be 10 to the negative 6. 10 to the negative 6 equals 10 to the negative 6. So when you have a pH that's a whole number, it's really easy because you're just going to take the negative value of that whole number and put it in your exponent in scientific notation and say 1 times 10 to and give the negative value of the pH. In the next one, we have the pH equal to 9. Again, this is a whole number, so all I have to do to find the concentration of hydrogen ions is put the scientific notation 1 times 10 to and write the negative 9. Just the negative value of the pH. It gets more complicated, however, when we have 4.2, because we're not allowed to say 1 times 10 to the negative 4.2 because we don't write scientific notation that way. We don't put decimals in the exponents. So this isn't acceptable. But that's exactly what we're trying to do. What we're trying to do is raise 10 to the negative 4.2. So we're going to use our calculators to do that. In your calculator, put in 10. Then you can press the key that is x to the y, and then you can put in 4.2, and remember to change that to a negative sign by pressing the plus minus key. Then it equals. Your calculator could spit out a big number like this: 0.000063095, etc. I can then just convert this to scientific notation. You guys remember how to do that? We're just going to say I'm moving my decimal 1, 2, 3, 4, 5 places. Because I started with 2 digits, I'll use 2 significant figures in my mantissa. 6.3 times 10 to the negative 5. I've just taken this number here and put it in scientific notation with 2 digits as 2 significant figures. Sometimes in your calculator, if you have something like pH equals 12.5, it's going to give us our number. We'll stick this in the same way: 10 x to the y, 12.5 negative equals, but the number that comes out of it is going to look like this: 3.16228 minus 13. This right here is just telling you that they're putting it in scientific notation for you. So there we had e minus 13. That's going to be our exponent. What we're going to do is look back up here at the pH. It was 3 significant figures, 12.5. So we want to put our answer with 3 significant figures. So I'm going to say 3.16 times 10 raised to the negative 13. And that's my answer. This right here, that is just telling us what the exponent is when we have scientific notation. So it's going to be negative 13. I hope that clears things up for you. Good luck on your worksheet.